So in this video, we will be discussing the manipulation of Kc for a reaction with different coefficient. We know that the equilibrium expression or the reaction coefficient expression depend directly on the coefficients of the reaction. Therefore, if we multiply a reaction by a common factor, it makes sense that we can find a relationship between the two Kc values. So for calculating the value of K or the Q, which is the reaction coefficient for a reaction with coefficients multiplied by a common factor, we're going to discuss the following example dealing with the formation of aerosols of sulfuric acid, which is just acid rains. So one way to write down this chemical equation is as explained by equation A. Okay, as you can see, the coefficient in front of sulfur dioxide is 1, and in front of oxygen is 1/2, and then the sulfur trioxide has a coefficient of 1. In this statement, they are giving us the value of Kc for this reaction at 298 kelvins. This value is 2.8 times 10 to the 12. The question will be, what will be the Kc value at the same temperature for a second reaction, for the following reaction, which is expressed by the equation B. As you can see, right, between the two equations, the main difference is multiplication, right? A factor that we are multiplying the first equation to obtain the second one. If you see, right, if you multiply the first equation by 2, you get equation B. But how can we get, right, like an real understanding on how the Kc of equation B relates to equation A? So let's write down the Kc expression for equation A. For clarification, we're going to use the subscript A here to just refer to the first one. So remember, the Kc expression is the multiplication of the concentrations of the products raised to the power, which means to a power that is equal to the coefficient in the chemical equation, and divided by the concentration of the reactants, okay, again raised to the coefficient in the chemical equation. Something similar is done with the equation B. Okay, for clarification, again, we are using the subscript B to refer for the Kc for that equation. As you can see, again, is the products, right, raised to the coefficient divided by the multiplication of the concentrations raised to the corresponding coefficient. If you look at this, okay, equation in terms of the chemical equation, okay, equation A, okay, and B, you can see that the common factor between the two equations is a 2, right? We're multiplying the equation A by a 2, and then we get equation B. However, when you see the Kc value of B, you see a common factor that is 2, but it's not that we are multiplying the Kc expression by 2. It is not doubled, right? The equation, the Kc expression for A. We see that what we are really having is that we are basically raising the whole Kc for the first equation to a power of 2, that it turns out that the same common factor that is the equation be multiplied with. So it's very common for students to think that the Kc value is being doubled due to the common factor that you find out, but it's not, okay? It's raised to that number, right? The previous one to get the second one. So let me put it in numbers, okay? So equation B is obtained when you multiply equation A by a factor, a common factor of 2. So I'm going to just write down n equals to 2, okay? And we see from the expression of equation B that Kc, okay, of B equals to Kc of A raised to that common factor, okay, which is equal to n, okay? So if we put this, okay, expand this, we can get, right, if I'm going to open the parenthesis, I'm going to rewrite my Kc expression for A. I end up with an expression like this. If I continue with my math, okay, I'm going to continue here. So SO3 sulfur trioxide, elevated to the raised to the 2. Okay, I'm going to do the same thing in the denominator. O2 to the 1/2 times 2, right? This cancels out, right? We end up with a 1 here. And if you look, okay, I'm going to just change color so you can refer again to the original Kc expression for equation B. We end up exactly, right, with the same expression. So in a generalized form, right, we can see that when we have a second equation that is a multiplication, right, and we identify which one is the common factor, we can conclude, right, that the Kc expression for that second equation, right, I'm just saying B, is equal to the Kc expression of the first one elevated or raised to the common factor that identified. And just like that, without the need of doing any experimentation, we can have, right, a calculated value for the Kc of equation B. Okay, this is based on the statement, equal to 7.8 times 10 to the 24.